One of the advantages of going towards the end of the day is you find that most people have talked about everything you're going to talk about, so they've already set the scene, which is fantastic. I'm going to touch a little bit on one of the areas that we at PragmatIC have become interested in over the last several years, and this is around IoT and how this can potentially transform waste reduction and recycling. So many of us have become very fired up about the circular economy and sustainability. We've heard about themes of climate change. There's been millions of people marching, many school children in particular over the recent weeks. And plastic in particular has been in the firing line from politicians and public alike. You just have to remember popular programs like the BBC's Blue Planet that highlighted the choking of our oceans by plastic and the devastating impact that can have on sea life. We see it on our beaches being washed out to sea, and we see litter in general continue to be a scourge around our towns, our cities, and our countryside. And then we have problem plastics, like coloured or black plastics, which is often what our food is transported in. Very difficult to separate, very difficult to identify, and to recycle. Food waste in general. It's about a third of the food produced is wasted or lost according to EAT, and that's enough to feed the world's hungry 4 times over. So what's the problem here? Many of us will try and do the right thing, we'll religiously put things in the right bins, but do we know about the problem waste that can't be recycled? Do we know where it goes, being exported to places like China? Or that now become even difficult because they're applying more stringent requirements onto that plastic waste? Or the confusion caused means that people just throw it away in the bin. If in doubt, chuck it out, because there's no consistency from town to town, from city to city. We heard about Germany with the app for telling you about the right bins. Well, in the UK, we just don't have that consistency yet. And despite promises from government and industry, last week we had Sainsbury's saying by 2025 they're going to halve plastic packaging. We just don't have the rate of recycling and the infrastructure and the capability yet to achieve that. And in places like the US, we're going backwards. So we need a sea change, and not just in the oceans. So, of course, plastic isn't all bad. It does some things very, very well, like protecting fresh produce. So take a cucumber, for example. A wrapped cucumber will last 3 times longer than an unwrapped one. So it'll lose about 1.5% of its weight by evaporation if it's protected in plastic, whereas it'll lose more than twice that within just a few days if it's not. Plastic is much lighter than things like glass and metal, which means transporting goods in plastic takes less transport costs, it takes less carbon. It's also waterproof. It doesn't absorb water like paper, so it's much more robust. It's flexible, it's very versatile, and it takes less energy to produce. And that means it's very cheap, and this actually gets to the heart of the problem. It's too cheap. It's so cheap that until now, the reuse and recycling of plastic has not really been seen as a necessity. Since the 1950s, we've grown an increasingly disposable culture in society that's been based primarily on plastic. But we have seen some wins there, some changes in behaviour. So in the UK, we had the plastic bag levy, and even at a modest 5 or 10 pence per bag, it was enough to change behaviour. It was enough for people to feel guilty enough that they would carry items to the car rather than pay for a plastic bag. So it's possible to change behaviour with the right kind of approach. We also see companies like TerraCycle with their innovations loop, where they're promoting us going back to that old style of reusing packaging and refilling that. So how can we enable that? How can we automate that? How can we help people to make better choices? One of the fundamental problems here is that the confusion causes the waste. And the inefficiency is about what I can and can't recycle. I had the same confusion this very morning. Just for breakfast, I got some plastic with some raspberries in there. I had it on my breakfast. I'm like, well, why can't I recycle this in my hometown when I know that it can be done in the neighboring town? It's really frustrating. And within the waste management system, there's problems around, has the waste been transported in the right way? Can you trust it? Can you mix the waste? So a good example of this working, if you look to Germany again, they have a deposit return scheme. And this is for plastic bottles, glass bottles, and aluminium cans. And they have what they call reverse vending machines in supermarkets. You can take your items, put them into the vending machine, and you get a token or a deposit slip back that you can offset against your future spend. And this means that in Germany, less than 3% of bottles are not returned. We used to have this in the UK with glass bottles, but we went away from that kind of system. And it means you have a circular process. You've got far fewer raw materials being used at the beginning of that, and you've got much less carbon that's wasted as a result. If you replicated this globally, you could save millions of tons of CO2. So what if we could associate a unique ID, a digital identity, with every single product? What could we do with that? We could associate data or information with that product throughout its entire life cycle. So at the start of life, you could look at the provenance of the goods. You could look at the manufacturer. Do they use sustainable materials? Do they have good governance? Can I trust them? Do they share my values? Do they have systems in place that will allow them to go back and in a product recall, identify the problem batches and minimize the waste? Into the supply chain. Can I reduce the amount of stock that I need to hold through automation? Can I reduce the amount of waste? So one of our partners, Avery Dennison, who's a global leader in RFID, they estimate they can reduce food waste by 20% simply by ensuring that food is sold in time before its sell-by date expires. That's massive. 20% is massive. You can extend that further, and you can actually think about eliminating sell-by dates. So one of our other partners, Arm, we're working with on sensors. You can extend that kind of approach to have sensors on packaging for food, so you can detect when food is starting to near its end of life, and you can dynamically adjust pricing, or you could dynamically adjust the temperatures of fridges to extend the life, or to reduce the amount of energy. Within the home, you could start to connect with devices like Alexa to give information and automatically read from packages. You can authenticate that you have genuine goods. You can give people information about how to use products, how and where to recycle them in an automated way, reordering of products as well. So there's some benefits there for the brands. Many of us are concerned about where our goods come from and taking more responsibility for that. So you could look at, for example, whether you're trying to reduce meat or not, or if you're just looking at where it came from. We know that cattle that are grazed on deforested land have a much higher environmental impact than those grazed on natural pastures. So this is information that you can get automatically with a machine-readable label. And then into the waste collection stream, we can encourage more deposit return schemes. We can make this easier and more automated. We can have smart bins that allow you to identify which bin automatically your waste needs to go into. And then that extends into the waste sorting, so making it easier to separate the waste into the right stream so they can be reused or recycled, or if necessary, incinerated, but done without contamination to minimize the impact. All of this data is rich, big data for machine learning, so you can start to build up trends of how waste is moving and start to allow legislators, which we touched on earlier, to develop policies built on data that can be much more informed. So I'm going to segue slightly now into a real case study. It is really car tires, and I'll come to that. We work with DEFRA, which is the UK's Department for the Environment, Food and Rural Affairs. And with them, because we're not waste management experts, they helped us to identify some of the requirements and characteristics in this sector. And what we found was that there was quite a lot of manual processing of small parcels of items or individual items like car tires or bags of hazardous waste. Being able to uniquely identify those with a digital identity was very important, because often the movement and location of that waste is a requirement for audit and compliance. And this then led us to a project with the Tyre Recovery Association and one of their members, Fraser Evans and Son. And the TRA is an industry federation that manages a responsible recycle scheme in the UK, and its members guarantee that they will collect, reuse, reprocess, recycle the tyres in an environmentally friendly manner using best practice methods. There are more than 40 million tyres enter the UK waste stream each year, and there are problem weights, and actually more than 14,000 incidents of fly tipping just on public property involve car tyres. So what we did with the TRA was we were able to provide electronic labels that were readable with a handheld scanner, and they could assign these to a tyre at collection and assign a purpose for that, whether that was retreading, reprocessing, and then build up data around the movement of that through the process and trends there, and get more accurate insights into the number of tyres collected, which is important for automated invoicing and compliance purposes. So we were able to give them much richer insights into their data, the reports, insights, and the tracking of that. There are many other examples in other industries where this can have a similar kind of impact. We also have one with the UK NHS around medical samples, which I'll be happy to talk about later. So this all sounds great. Why don't we just put a unique ID, an electronic ID, onto every single object? Well, the fundamental problem is that today's incumbent technologies based on silicon are just simply too expensive to enable that to happen. What we've developed at PragmatIC is a new type of technology, a new type of electronics. It's very thin, very flexible, ultra low cost, and it scales into billions of units. And we've developed this over the last several years, and we've worked with world-leading companies like Arm and Avery Dennison and Cambridge Innovation Capital to take this from the lab into the fab. And it allows us to get to a cost point where we can envision putting these electronic labels, these machine-readable labels with smartphone-readable capability onto everyday objects. So our vision is to become the de facto standard for IoT on everyday objects. And our bold prediction for the future in the waste management stream is that within the next decade, we'll scale our technology to reach 1 trillion items, which will transform areas like waste reduction and recycling. Thank you very much.